Hi everyone, welcome to this video about how to simplify fractional exponents. Before we get started, I want you to take a moment to tell yourself something that you really appreciate about yourself. I feel like this is something we don't do often enough, but when you love yourself, it makes everything in life a lot easier, including math. So take a couple deep breaths, give yourself a little bit of love, and let's make this math easy. When you're simplifying fractional exponents, the first thing you need to know is that they're the exact same thing as rational exponents. So a rational number is a number that can be expressed as a fraction, and so the term rational exponents is just a more formalized math term for fractional exponents. So if you see something talking about rational exponents versus something talking about fractional exponents, they're the exact same thing. On my YouTube videos, I separate them into two different types of problems to make it easier for you to learn. So in this video, I'm going to talk about how to simplify a very simple exponents that are fractions where the numerators are 1. And then in my video that's called How to Simplify Rational Exponents, I go into more advanced ones where the numerators are things other than 1. But there's actually not a difference between the two types of exponents. I just separated them that way to make it easier to teach the simple concept first and then teach the more advanced concept. So after you watch this video, if you want to go see how to simplify the more advanced ones, you're welcome to do that. So when you're simplifying fractional exponents where the numerator is 1, the denominator of the fraction is going to tell you what type of root to apply to the base. So in this case, 36 is the base of the power, and the denominator of the exponent has a 2, which means that you're going to do a square root. And the square root of 36 equals 6. So your answer would be 6. If you do this one, you have a denominator of 3, which means that you're going to do the cube root of 8, which equals 2. Because 2 times itself 3 times equals 8. So the cube root of 8 equals 2. On this one, you would do the fourth root of 81, which would equal 3, because 3 times itself 4 times equals 81. And on this one, you do the cube root of 64, which would equal 4, because 4 times itself 3 times equals 64. And on this one, you do the square root of 25, which would equal 5. So the basic idea here is that the denominator of the fraction tells you what type of root there is. So if you have a 2, it's a square root. If you have a 3, it's a cube root. If you have a 4, it's a fourth root. And that's how you simplify fractional exponents. The reason why you simplify it this way can be figured out if you look at the pattern of how exponents work. So if you list out all of the positive exponents and also the negative exponents, which you can watch one of my other videos if you don't know how to do negative exponents. But if you list all of those out, you'll notice that 9 to the 1/2 power has to go somewhere in between 9 and 1, because 1/2 is somewhere in between 1 and 0. So your first inclination might be, oh, well, like maybe it's 4.5, because that's halfway between 1 and 9, which is a good thought, but it's actually not accurate, because 4.5 would be if you were doing 9 times 1/2. But this is 9 to the 1/2 power. And so the 1/2 power means that it's the square root of 9, which equals 3. And the reason we decide to use roots to represent these powers is because of the power rule of exponents. So the power rule of exponents means that if you have a power to another power, you can multiply the exponents to simplify it. And the reason it works is because in this example, if you had x squared to the third power, you'd have x squared times itself 3 times, which gives you a total of 6 x's. And so if you apply the power rule of exponents to a fractional power, where you have a fraction and then the reciprocal of that fraction, and they're being raised to each other, so like x squared raised to the 1/2 power, the power rule of exponents says that that should equal 1, because 2 times a half equals 2 halves, which is just 1. And so if you look at that and you say, okay, well, the 1/2 power, it basically needs to be able to undo the squared so that you get back to x to the power of 1, which is just x. So if you think about, okay, well, what undoes a square? The thing that undoes a square is a square root. And the square root of x squared is just going to give you x. And so that's why we do fractional exponents as roots. And obviously, if you had something like x cubed, the thing that would undo an x cubed to make it equal just x to the first power would be a 1/3 power. And that's the reason why a 1/3 is a cube root, because a cube root will undo an x cubed. And x could be any number. I just chose x because it's a nice variable to represent an unknown number, but it could be any number or any other variable. So to summarize, the way that you simplify fractional exponents is you look at the denominator of the fraction and you use that to determine what type of root, whether that's a cube root or a 4th root or just a simple square root. And if you want to write a formula down in your math notes to help you remember this, you can say that x raised to any number or any fraction with n in the denominator is going to equal that number with the nth root. So n could be a 2, which could be a square root. It could be a 3, which could be a cube root. Or it could be something crazy like an 8th root, where you'd have to figure out what the 8th root of the number is. So that's how you simplify fractional exponents. I hope this video was helpful for you. Please comment below to let me know how easy this was for you, and then subscribe. For more help with exponents, check out my exponents playlist here on YouTube or go to mathtutoringonline.com to get additional help by asking a question or booking a one-on-one tutoring session. See you soon!